Okay, we meet again to talk about the most basic of carbohydrates as a food component. Okay, we continue from part 1. We talk about Maillard reactions and caramelization. We agree that this is due to sugars. You see the brown color, very likely this particular meat is going to be very tasty, and we agree this is due to sugars. But is it due to the Maillard reaction or is it due to the caramelizations? You will be surprised to learn that it is due to both. But how come there are so much sugar? Well, first of all, maybe during cooking somebody has put some kind of maybe honey or maybe some syrup on the surface of the beef. But there is also ribose, which is a kind of very reactive reducing sugar in the meat itself. So I mean, this ribose can react with the amino acids of this high protein food and yielding color and flavor. And some sugars may undergo caramelization. If you ask me which one is more important here, I would say it is the Maillard reactions. Okay. Alright, so next one we look at another aspect of sugar, which is actually crystallization. You see, sugar can exist in two states, either as a crystalline, or a syrup, which is the soluble state. In crystallization, units of sugar organize in three-dimensional arrays into solid form. Well, when sugar is solid, it is actually a three-dimensional arrays of crystals. It is a solid made of sugar units in repeating patterns. I don't have the figure there, but we can show in class. When sugar form structure of crystal, they can be desirable, or it can also be undesirable. So when we make table sugar, the manufacturing of table sugar, we purify the sugar into the crystal form, so that is desirable. When you make hard candy, like maybe you're familiar with Hacks, a kind of hard candy, that is also desirable because you don't want sugar to melt, because it's very difficult for you to package it. So when you form crystals, it's easy for the manufacturer to sell the hard candy one by one. So how they make it? They melt sugar upon heating, and when the sugar is cool, when the melt is cool, it becomes crystal. It recrystallizes into different crystal size and form. However, the crystalline structure may be undesirable in certain product like ice cream. I mean, when you enjoy the ice cream, you want it to be smooth, right? You want the ice cream to have very smooth texture and do not have this large sugar crystal. It's going to be disturbing the enjoyment. So that is undesirable crystal structure in ice cream. Or when you use condensed milk, you do not in the milk itself, you don't, when you drink the milk or you use it in other kind of dishes or product, you do not want the product to be coarse or gritty or graining, we call it. Okay, so I want to show you the process of making sugar. Well, you're going to learn how complex the process of making sugar, but for this particular course we want to be as simple as possible. I'll start with a clarified sugar cane. Then we evaporate in evaporator. It's boiling, Because of that boiling and evaporation, we produce very thick syrup, and then it's going to go low temperature boiling under vacuum, and then we add something called seeding during this low temperature boiling under vacuum. With addition of seeding, we're going to see a development of crystals with molasses. Okay, don't worry, what we are interested to know is how the sugar being formed. There's a sugar crystal still with molasses, and then we undergo a process of centrifugation, where we separate sugar crystal from molasses. Molasses is like that. It can still be used for other purpose, but at this moment we are interested in this sugar crystal. Okay, the vacuum being applied there, the evaporation of water from syrup produced under vacuum, because it will avoid high temperatures. High temperature can damage the sugar molecules. We do not want to boil under very high temperature, so we apply vacuum to reduce the temperature effects. Okay, crystallization can be summarized. I'm talking about the kind of process in this state only. This is called crystallization, because we form crystal here. Okay. So we summarize here: formation of solid crystal precipitating from a solution or melt. Okay, and the most important events here is first nucleation and then growth. Initially in the solution or in the melts, it is just like this, they are very, very far apart. So when the process of adding seeding, this is the seed for crystallization to happen. So they're starting to become clustering together, one molecule to another molecule. Eventually, because of that seeding, seed was added. I don't know, can't remember the name of the seed, but anyway, because of that seeding, the nucleation between molecules start to occur. They come together and they join together, and if you leave it to grow, the size of the molecules start to become bigger and bigger. Eventually they become what we call them crystal. So this is the crystal. That is the sugar that we know them as say table sugar, or sugar crystal. Okay. Alright, so another property of sugar is the humectancy. This is just anything with affinity for moisture. Okay, you leave sugar on the table, you leave it there in the high relative humidity. You will see tomorrow morning you will see the sugar will absorb moisture. It is hygroscopic. It attracts and retain moisture, and we know it has this ability to form hydrogen bond with water molecules. Therefore, in certain applications, this is good, because we can make water less available for microbial growth. This is how we use sugar as preservations. Well, you learn this in food processing and preservation later on. Okay, so CHO, especially sugars, are used in food to influence the state of water. Fructose is more hygroscopic than sucrose, so you can use fructose in certain food system to reduce water activity. Sucrose, on the other hand, is less hygroscopic and is thus more free flow. That means for dry mixing or during packaging, it is more advantageous to use sucrose than fructose. It is not a good idea to use fructose in, say, 3-in-1 coffee, during blending, etc., the fructose has higher tendency to attract and retain moisture. Okay, never mind about the inversion, we can skip for now. Finally, I'm going to summarize polysaccharides and their functional properties in general, especially the complex carbohydrates. Just now we just talk about sugar. Now we go into complex carbohydrate, only one slide. You can separate between the two of the complex. One is called oligosaccharide, very well known these days because of the health properties of the oligosaccharide. It can be 10 or fewer sugar units. Most of these are of course non-reducing. Things like raffinose, stachyose, these are poorly digested, and therefore it can be fermented in large intestine, not in a good way, because it will yield gas and may cause flatulence. You will fart a lot. So a good source will be like beans and soybeans and peas. Anyway, these days oligosaccharides have been recognized as a functional ingredient. It means good for health. Things like fructooligosaccharides, FOS, inulin, these are all being sold as healthy oligosaccharides. Of course, healthy, even though it is healthy, but if you take in excessive amount, it can still give that thing gas. You will fart a lot. Anyway, polysaccharide is the bigger polysaccharide, longer chains, 40 or more sugar units. Potentially hundreds more may contain reducing and non-reducing ends. So compared to oligosaccharides, polysaccharide have a higher occurrence, and they occur more frequently. And you will learn again, like fructooligosaccharide, beta glucan is very famous, one of the most famous functional ingredients in food. You will find this a lot in oats, in barley maybe. So they're also well known in the health food sectors. Okay, and many other polysaccharides. Cellulose, dextrin, phos is supposed to be an oligosaccharide, and then pectic substances that people we use for making jams, starches, starch, and some gums. Okay, I hope this is done for now. Second part of the carbohydrate that we need to know. Very basics, but very important introduction for you before you step into real food chemistry. Okay guys, so happy learning.